All right, class. This are the notes for graphing a function rule. The notes for graphing a function rule. So our learning target is to graph equations that represent functions. The key concepts, of course, you guys should already know that a pair of values, the x and y values, are called the ordered pairs, and all ordered pairs that satisfy the equation is called the solution set. So once again, the pair of values, x and y, those are your ordered pairs, and all ordered pairs that satisfy the equation is called the solution set. And we've talked about this already about an equation whose graph is a line. That is a linear equation. So keep that in mind. Any equation's graph is a line, that's a linear equation. So if you look at the first example here, graph the solution set for the linear equation -3 plus y equals x subtract 2. I'm sorry, -3x plus y equals -2. -3x plus y equals -2. So before we can graph this, we need to solve to get y all by itself. So we need to go through the steps to solve this to get y all by itself. So to get y all by itself, all I simply need to do is get rid of this -3x. So to do that, I'm going to add 3x to both sides of my equation. So now that I've added 3x, I now have y equals 3x subtract 2. Or I can write this as y equals -2 plus 3x. It really doesn't matter. We like to have it in this first form here, y equals 3x subtract 2, because that's the slope intercept form. We'll talk more about slope intercept form later. But I have my equation, y equals 3x subtract 2. So this is my equation here. Now all I need to do is get some ordered pairs. Get some ordered pairs, and I can plot those ordered pairs, then I'll have the graph of my equation. So my ordered pairs are my solution sets. So what I did here, I chose my x values of -2, 1, I'm sorry, -2, -1, 0, 1, and 2. -2, -1, 0, 1, and 2. So when I plug in -2 into my equation, y equals 3x subtract 2. When I plug -2 in here, 3 times -2 is -6. -6 subtract 2 is -8. So when x is -2, my y value is -8. When x is -1, 3 times -1 is -3. -3 subtract 2 is -5. My y value is -5. So when x is -1, y is -5. If I plug in 0 here, 3 times 0 is 0. 0 take away 2 is -2. So when x is 0, our y value is -2. Likewise, when x is 1, y is 1. And when x is 2, y is 4. So these are all my solution sets that I need to graph. So my solution sets are just my set of ordered pairs. So I have -2, -8. I have -1, -5. I have 0, -2. I have 1, 1. Then I also have 2, 4. So these are my solution. This is my solution set. So at this point, I just need to plot my ordered pairs. So I plotted the point -2, -8 here. This is the point -2, -8. This is the point -1, -5. Here I have 0, -2. Here I have 1, 1. And then the final point is 2, 4. So I have my ordered pairs plotted. So now all that I need to do is to draw my line that connects them. So my line that connects I connect all my points. I'm doing this with a smart board, so it's a little more of a challenge for me to draw the lines properly. But with the pencil, it's a piece of cake. So there goes my line. That connects all those points. Of course, this is a linear equation. The line is straight. Put my arrows heads on the end of the line to show the line continues in both directions. So there goes the graph of the equation -3x plus y equals -2. All right, example 2. I have another equation. This equation is y equals 3 to the power of x. Y equals 3 to the power of x. This equation is not a linear equation. This is not a linear equation. This is an exponential equation. Once again, to graph my solution set, I choose my x values. I set up a table of values. So I chose, once again, I chose -2, -1, 0, 1, and 2 for x. So when I plug in -2 for x into my equation, y equals 3x, (3 to the power of -2 is the same thing as 1 over 3 squared. 1 over 3 squared is 1/9. That's 3 squared is 9, so we have 1 over 9. The next one, when x is -1, I plug in -1 for x, so I'm going to have 1 over 3 to the power of 1. 3 to the power of 1 is just 3, so my y value is 1/3. I plug in 0 for x, y equals 3 to the power of 0. Anything raised to a 0 power is just simply 1. So 3 to the 0 power is 1. So when x is 0, my y value is 1 for this equation. Likewise, when x is 1, my y value is 3. When x is 2, my y value is 9. So I have my solution set now for this equation. So once again, my solution set is my set of ordered pairs, -2, 1, 9. I have -1, 1/3. I have 0, 1. I have 1, 3. And then I have 2, 9. So there goes my solution set. Once again, my solution set is just my set of points that fall on this line here, or this curve. So I simply plotted those ordered pairs, and then I drew my curve there, represented by the red line, or the red curve. So this point here represents the point -2, 1, 9. This point here represents the point negative 1/3. This point here represents the point 0, 1. This point here represents the point 1, 3. And then I have the point 2, 9. So this is the graph of an exponential function. It starts off slowly, and then it grows real fast. So the red curve there represents that equation. All right, the last example, example 3, is an application problem. Family's going on vacation, and they're driving 1,000 miles to the beach for their vacation. They're traveling 60 miles an hour. So what that means is they're going to get 60 miles closer to their destination every hour. They're going to get 60 miles closer every hour. So here it says, write an equation that represents the distance remaining in miles and the time in hours they have been driving until they reach the beach. They plan on stopping 4 times during the trip. Draw a graph that represents all the possible distances and times they could stop on their drive. Alright, so distance equals how fast you're going times time. We can represent that relationship. Distance D equals 1,000 subtract 60 miles times the number of hours, which is T. So D equals 1,000 subtract 60T. Or I can use X and Y since we're more familiar with that at this point. I can call dy and call my Tx. So I can say Y equals 1,000 subtract 60x, where Y is the distance remaining, X is the time in hours. Y is distance remaining, X is the time in hours. All right. So I have my table of values here, 0, 2, 5, 10, and 15 for my hours, 0 hours, 2 hours, 5 hours, 10 hours, 15 hours. And if I plug those into my equation, the Y stands for how many miles I have remaining. So at 0 hours, clearly I have 1,000 miles remaining. After 2 hours, which I've driven 60 times 2, which is 120 miles, I now only have 880 miles remaining. After 5 hours, I have 700. After 10 hours, 400. After 15, I only have 100 miles remaining. So that's the relationship there. Those are my ordered pairs. Those are my solution sets. 0, 1,000, 2, 880, 5, 700, 10, 400, and 15, 100. So now that I have my ordered pairs, I have my solution sets, I go and plot those points on my graph. And based on what it looks like there, it looks like this is a linear equation. This is a straight line, so I have a linear equation here. And now I have graphed the equation that represents the Russell family traveling to their vacation destination. And that's it. So those are our notes for graphing a function rule.